Do you know what the most dangerous moment of a Chinese rocket launch is? It is not the ignition, it is not during flight, and it is not when the satellite enters orbit. It is the moment it comes back down to Earth. And by coming down, I don't mean crashing into the ocean. I mean crashing straight into villages in China's Guizhou, Hunan, and Shanxi provinces. We're talking about dozens of tons of twisted metal packed with unburned, highly toxic rocket fuel, smashing through roofs, poisoning farmland, and sending villagers to the hospital. Yet, this is something you'll almost never see in official news reports. Why do rocket debris keep raining down on civilian homes? Why, during that infamous 1990s explosion in Xichang, were Americans secretly filming from inside their Su versus, and why, years later, when the 5th of March B was launched, did the entire world stay up all night staring anxiously at the sky? Over the past few decades, as China claimed its stake in deep space and built its own home in orbit, what was the real cost behind it all? And who is the one paying the price? Let's start with a basic rule of physics. When you launch a rocket, you have to factor in Earth's rotation. At the equator, the planet spins at about 465 meters per second. That is more than twice the speed of a commercial airliner. If you launch in the direction of that rotation, meaning straight east, the rocket gets a massive free speed boost the moment it leaves the ground. It is like getting a heavy push from behind just as you start pedaling a bike. The fuel saved from this little trick translates into tens of millions, sometimes over $100 million. This is exactly why the world's space superpowers build their launch sites as close to the equator and the ocean as possible. The lower the latitude, the bigger the free initial velocity you get from Earth. And being next to the ocean is crucial for another reason. When the rocket's first stage burns out, that massive, multi-ton metal shell has to fall back down. Dropping it into the ocean is perfect. It hurts nobody, and you don't even have to clean it up. Look at America's Cape Canaveral. Its eastern horizon is the vast Atlantic Ocean. France's Guiana Space Center in South America faces the South Atlantic. Russia didn't have that luxury since most of its territory is too far north, so they put their main site in Baikonur, Kazakhstan. It is at a decent latitude, and more importantly, everything to its east is the vast, uninhabited wilderness of Siberia. So, what about China? Spread out a map of China. Its three earliest launch sites are Jiuquan, Taiyuan, and Xichang. If you take a ruler and draw a straight line directly east from these 3 points, look at what lies along that path. East of Jiuquan, Inner Mongolia, Shanxi, Henan, and Shandong. It is a straight shot through some of the most crowded regions on Earth. East of Taiyuan, Hebei, and Shandong, both massive, heavily populated provinces. And east of Xichang, Guizhou, Hunan, Jiangxi, Guangxi, and Guangdong. Endless mountains where tens of millions of people actually live. And that is where the nightmare begins. Why on earth were these launch sites built in places like this? It is not that Chinese engineers didn't understand geography. It was because of a turbulent period in the 1960s and 70s known as the Third Line construction. With hostile relations with the Soviet Union and no diplomatic ties with the US, China faced a very real threat of nuclear war. The survival doctrine for all critical industries, research labs, and military bases boiled down to 6 words: disperse, hide, and move into mountains. They tucked everything deep inside the canyons of the Northwest and Southwest to prevent a single preemptive strike from wiping them out. This strategic gamble saved the lifeblood of Chinese industry, but it also left a lingering side effect that remains unresolved to this day. To catch that free ride from Earth's rotation, those rockets hidden deep in the mountains, famous fly east. And when they fly east, their entire flight path is lined with civilian homes. As a result, from the 1990s through the 2000s, and even to this very day, every single time China launches a major rocket, local governments in the provinces directly beneath the flight path have to trigger emergency protocols as if bracing for a Category 5 hurricane. Local militias march through villages, barking orders through megaphones, going door to door. Convoys of buses, heavy trucks, and even farm tractors line up to haul thousands of villagers to open fields kilometers away. Grandparents carrying sleeping toddlers, young people dragging reluctant livestock, all evacuating in the pitch black at 3 or 4 in the morning. It is a massive, chaotic relocation of tens of thousands of people, all just to wait out those crucial few seconds when a screaming, multi-ton hunk of metal tears through the sky right above their heads. Once the rocket is gone and the all-clear is given, they pack everyone up and ship them back home. Think about the astronomical administrative costs of an operation like this. The disruption to the local economy, the absolute chaos inflicted on ordinary lives. Who do you think foots the bill? The space agency. Local municipal budgets are forced to swallow the costs themselves. And here is the kicker. It is not just twisted metal falling from the sky. If you've ever watched videos of early Chinese rocket launches, especially the older models like the Long II of March 3 or 4, there is a highly jarring image that always stands out. A massive thick plume of reddish, brown smoke trailing behind the rocket like the tail of a giant poisonous snake. On state TV commentaries, they call it a spectacular contrail or the flames of soaring glory. But in chemical engineering, that is the byproduct of UDMH, unsymmetrical dimethylhydrazine, and nitrogen tetroxide. You don't need to memorize those names. You just need to know 3 things. First, these 2 chemicals ignite the exact moment they touch each other. No spark plug or lighter needed. In military logic, this hypergolic property is a massive advantage. ICB missiles sitting in their silos can be stored at room temperature with this fuel inside for years, ready to launch at a second's notice. In a nuclear war, taking hours to fuel up a rocket is a luxury that gets you wiped off the map 3 times over. Second, both chemicals are extremely toxic. UDMH smells like rotting fish, is highly carcinogenic, and aggressively destroys your central nervous system. Nitrogen tetroxide, upon hitting the air, turns into nitrogen dioxide, that signature reddish-brown toxic cloud. If you breathe it in, it reacts with the moisture in your lungs, instantly forming a powerful acid inside your respiratory tract. It is essentially like washing your own lungs with diluted sulfuric acid. And third, when rocket debris falls back to Earth, the fuel is rarely completely burned out. Imagine a massive 50-foot booster smashing directly into a terraced rice paddy in Guizhou. The internal pipes rupture, and hundreds of kilograms of remaining propellant leak straight into the local environment. This explains why, in those old photographs, you often see heart-wrenching scenes, crowds of villagers who have never left their remote mountains wearing simple cloth shoes and cradling their babies, smiling and laughing as they gather around the smoking wreckage, pointing fingers. Some even reach out with their bare hands to touch the scorching hot metal hull. They had absolutely no idea what that smoke was. They didn't know that standing there for even an extra minute meant trading their lungs for curiosity. Did the local cadres know? Maybe a fraction of it, but who was going to explain it? Who could possibly explain to uneducated villagers in words they could actually understand that nitrogen tetroxide turns into lethal acid upon contact with moisture? The result was devastating. In the years that followed, many villagers living in those debris drop zones developed mysterious respiratory illnesses, liver diseases, and cancers. Did these count as workplace injuries? Were they classified as state-inflicted harm? Did the government cover their medical bills? Did the local budgets have any spare cash to conduct long-term epidemiological tracking? On the financial ledgers, these lives were simply filed away as untraceable costs. This isn't about pointing fingers. If we pull back the lens of history, this practice of trading human lives for technological speed was something the US and the Soviet Union did during the Cold War, and they did it 10 times worse than China. In 1980, inside a Titan ICBM silo in Arkansas, a maintenance worker accidentally dropped a heavy wrench socket. The tool plummeted down and punctured the missile's fuel tank, causing a massive UDMH leak. Hours later, the entire silo erupted in a violent explosion, blowing a 740-ton reinforced concrete door sky high, leaving 1 dead and 21 injured. The Soviet Union had it even worse. In 1960, an ICBM loaded with hypergolic propellants accidentally ignited right on the launch pad. Over 100 of the nation's top rocket scientists, along with a marshal of the Soviet Air Force, were instantly vaporized into dust. The Soviet government locked this tragedy away, keeping it a state secret for half a century. When superpowers race for space dominance, the underlying logic has never been about perfect safety. The raw, unvarnished truth is this. In the face of national security, individual health and local environments are calculated as nothing more than an acceptable marginal cost. It sounds heartless, but that is exactly how the books are balanced. Everything we've talked about so far was the unavoidable price of technical limitations. But what happened in Xichang in 1996 was different. That was a pure, bloody commercial disaster. Flashback to the 1990s. The Cold War was over, and the global demand for telecommunications satellites was skyrocketing. Satellite manufacturers in the US and Europe had a massive backlog of payloads waiting to go up. But domestic launch schedules were booked solid for years out, and they were insanely expensive. Enter China. Having just opened its doors to the outside world, China's space program brought an offer to the negotiating table that Western capitalists simply couldn't refuse. Our Long March rockets have plenty of capacity and will fly them for 1/3 of the international market price. Industry titans like Laurel and Hughes Space calculated the numbers and realized the deal was a steal. Launching with China would save them enough cash to build half a satellite. And so, on the 15th of February, 1996, just 1 day before the Chinese Lunar New Year's Eve, the Xichang Satellite Launch Center was packed. The control room was a mix of Chinese technicians, dozens of American experts and engineers, and representatives from international insurance firms carrying massive multi-million-dollar policies. They were there to launch Intelsat 708, a state-of-the-art satellite built by Laurel. Its price tag alone was equivalent to the entire annual budget of multiple mid-sized Chinese cities' combined ignition. 2 seconds later, something went horribly wrong. Instead of screaming straight up into the heavens, the third of March B rocket banked sharply and angled horizontally, slicing a terrifying arc through the sky. It headed straight for a nearby settlement known as Maolin Village. Hundreds of tons of hypergolic propellant, that lethal mix of UDMH and nitrogen tetroxide, detonated all at once. A colossal fireball erupted, instantly turning midnight into broad daylight across the entire valley. 3 villages were instantly flattened, reduced to absolute rubble as a choking cloud of reddish-brown toxic fog swallowed everything in sight. 3 days later, Xinhua News Agency issued a brief official statement: 6 dead, 57 injured. But on the ground, there were dozens of American engineers carrying handheld camcorders, a rare technology in China at the time. During the chaotic, forced evacuation that followed, some of those engineers pressed their cameras against the glass of their vehicle windows, secretly filming the devastation along the roadside. Those videotapes eventually leaked to the outside world. The footage was grainy, but the content was chilling. Entire rows of civilian homes turned into jagged piles of brick, power lines snapped and strewn across roads, the air thick with reddish, brown dust, and traumatized villagers sitting in stunned silence amidst the ruins. By analyzing the density of the leveled houses from that footage and cross-referencing it with satellite imagery, U.S. intelligence agencies calculated a casualty estimate that was orders of magnitude higher than the official tally, a number that has circulated in hushed whispers throughout the international aerospace community ever since. The fallout from the 15th of February disaster was catastrophic. Over the next few years, international insurance conglomerates slapped China's rockets with premiums that skyrocketed to astronomical heights. The U.S. government seized the OPP opportunity to weaponize the situation, tightening its ITAR, the International Traffic in Arms Regulations. The law explicitly stated that any satellite containing even a single American-made component was strictly banned from being launched on a Chinese rocket. That embargo remains in full effect to this day. Can you imagine the kind of dark days China's space program had to endure back then? International orders completely dried up overnight. Domestic budgets were starved of cash, and top-tier talent was bleeding away. If you read the memoirs of the aerospace veterans from that era, every single line radiates nothing but pure, suffocating frustration. Fast forward to the year 2020. By this time, China's space program had undergone a massive upgrade. They built a brand new launch facility in Wenchang, Hainan, right on the coast. Flying straight east meant throwing stages into the South China Sea and the Pacific Ocean. Safe, clean, and perfectly placed. Better yet, the new generation of Long the 5th of March and 7 rockets swapped out the toxic chemicals for liquid oxygen, kerosene, and liquid hydrogen. The byproducts. Just water and carbon dioxide. Eco-friendly. It sounds like all the old nightmares were finally solved. Right? Think again. The crisis didn't disappear, it just evolved into something on a global scale. The culprit this time was the Long the 5th of March B. Not the standard Long the 5th of March, but the B variant. The standard version is a 2-stage rocket. Its second stage burns up completely upon re-entry. But the Long the 5th of March B was a different beast altogether. Custom built to lift the heavy modules of China's Tiangong Space Station. Each of these core modules, Tianhe, Wenchun, and Mengxin, weighs over 20 tons, roughly the size of a 10-story building. To blast something that heavy directly into low Earth orbit, China faced a brutal double whammy: their second stage hydrogen. Oxygen engines weren't fully mature yet, and the geopolitical clock was ticking. They had a razor-thin window to assemble their space station before the International Space Station retired, and orbital lanes were completely choked off by American commercial constellations like Starlink. Missing that window meant waiting another decade or more. So Chinese engineers made an incredibly aggressive gamble, a 1.5 stage configuration. What does that mean? It means the rocket drops the traditional second stage entirely. The 4 side boosters count as the half stage, and the massive central core acts as the first stage. At ignition, everything burns simultaneously. Mid-flight, the side boosters run out of fuel, detach, and splash safely into the sea. But that central core stage, a monstrous 100-foot, tall 21-ton cylinder, stays attached, burning all the way into low Earth orbit alongside the space station module. Once the module safely separates, that 21-ton spent rocket core, having achieved first cosmic velocity, is stuck up there. It can't just drop back down. It becomes a drifting, tumbling, uncontrolled piece of space debris, the largest single-body space junk created in modern history. Think about it, 21 tons is the weight of a heavy tank. a heavy tank hurtling 400 kilometers above our heads at a staggering 7.8 kilometers per second. And because it lacked any system to reignite and steer itself, there was no way to control when or where it would come down. It was a textbook uncontrolled reentry. Simply put, a 21-ton chunk of metal was going to fall out of the sky, and no one on Earth knew who it would hit. By all accepted international aerospace standards, rocket debris in the 20-ton class famous face feature a controlled deorbit system. This means installing an independent propulsion kit on the stage so that, upon mission completion, engineers on the ground can command it to fire backward, acting as a brake, and steer it precisely into Point Nemo in the South Pacific, the oceanic pole of inaccessibility, furthest from any human life, used explicitly as a spacecraft graveyard. Europe does it. Japan does it. The US does it. Even India does it. So why did China choose not to? The reasoning was simple. The long 5th of March B's payload capacity had already been pushed to its absolute limit by that 20-plus ton space station module. Installing a deorbit propulsion system and reserving tons of fuel just for braking meant the core module had to go on a diet, and crucial scientific equipment would have to be left behind on Earth. Faced with two choices, leave a suite of scientific instruments behind or risk an uncontrolled re-entry of massive debris, the decision-making chain of China's space program delivered a chillingly pragmatic verdict. The mathematical probability of hitting someone is just too low to justify sacrificing valuable payload. But just how low was that probability? The 5th of March B was launched into an orbital inclination of 41.5 degrees, meaning its potential crash zone spanned everything between 41.5 degrees north and 41.5 degrees south latitude. New York, Madrid, Beijing, Tokyo, Sao Paulo. More than 80% of the world's population lived within the lottery of doom of this drifting metallic giant. The official response was swift. 70% of Earth's surface is ocean. The actual probability of striking a human is extremely low. From a purely mathematical standpoint, they weren't wrong. But mathematics doesn't care how many millions of human lives are packed into that remaining 30%. In May 2020, following the maiden flight of the 5th of March B, the Rogue core stage roared directly over the U.S. East Coast, just 1 hour before it finally plunged back to Earth. If it had re-entered the atmosphere just 15 minutes earlier, a rain of hypersonic metal shrapnel would have shredded the skies over New York City. Instead, it crashed down right next to several rural villages in Côte d'Ivoire, West Africa, leveling a few houses. By some absolute miracle, no one was hurt that night. Most of the villagers happened to be outside enjoying the evening breeze, narrowly escaping disaster. In 2021 and 2022, the 5th of March B flew 2 more times, carrying the Wenshan and Mengshan lab modules. During those launches, scientists at the European Space Agency and U.S. Space Command pulled grueling all-nighters, eyes glued to computer screens, tracking the descending red orbital line. Global media outlets broadcasted 24-hour live streams. Humanity was collective, watching a game of global roulette unfolding right above their heads. In both instances, the remnants splashed into the open ocean. The gamble paid off. By the end of 2022, the 3 core modules of the Tiangong Space Station were fully assembled in orbit. By leveraging the cheapest, fastest, and most high-risk one, and a half-stage's blueprint, China successfully secured a crown jewel of geopolitical real estate in low Earth orbit. As for the terrifying all-nighters endured by billions of people across the globe, on the grand macro ledger of history, they weren't even worth being recorded. By this point, you might think, I am here to condemn or criticize, but I am not. This is simply a cold, analytical statement of fact. China's space program reached where it is today by making countless sober, brutal calculations under severe resource constraints. It didn't have the luxury of endless congressional funding like NASA, nor did it operate under the Soviet system, where costs simply didn't matter. From day one, China's space program grew up with a noose around its neck, technological blockades, tight budgets, and a suffocatingly narrow strategic window. In an environment like that, you are forced to choose. Do you go for perfect but slow, or risky but fast? You've already seen the answer. The farmers in the mountains of Guizhou breathing in toxic UDMH, the village consumed by a fireball on Lunar New Year's Eve in Xichang, the crushed roofs in Cifé d'Ivoire, and the sleepless nights endured by millions worldwide tracking the red line of the long the 5th of March B. All of these are just numbers on a financial ledger. No one wants to be that number. But someone always has to be. From 2,000 years ago, when this civilization forged the East Asian continent together through the brutal enforcement of unified weights, measures, and currency. Down to today's race for orbital real estate, the underlying doctrine has never changed in the grand pursuit of survival and expansion. If the cost makes mathematical sense, you pay it. I am not saying this doctrine is right. I am saying it is real, and the unvarnished reality of it all is far more deserving of our memory than any triumphant symphony or propaganda slogans about the sea of stars. The next time you watch a live stream of a rocket launch, and you see the chat flooded with praise for the heavy weapons of a superpower, take a moment to look closer. Ask yourself, what exactly is that reddish, brown smoke? Whose roof did that falling chunk of metal just smash through? And what happened to that villager who was forced out of bed to evacuate in the dead of night? The journey to the cosmos is magnificent, but grandeur has always been built upon the back of countless microscopic sacrifices made by ordinary individuals. This holds true for any nation on Earth. It is just that in China, because of unique constraints in geography, history, and resources, these costs have rendered themselves exceptionally tangible, exceptionally dense, and exceptionally silent. And it is precisely those things hidden in silence that deserve to be seen the most